Hello, welcome to the episode of RUSTAsia Station. I'm your host, Alan Wyma. Before we dive in, we're thrilled to share that RUSTAsia 2025 is just around the corner, happening on March 28th in Hong Kong. It's the ultimate Rust conference in Asia. We've got an incredible lineup of speakers, including Tim McNamara, Florian Gilcher, and many more, plus workshops and everything from WebAssembly to terminal UIs. Sponsors like ExpressVPN and Jane Street will be there, and they are hiring. Don't miss the chance to connect with the global Rust community and take your skills to the next level. Check out the full schedule, speaker lineup, and tickets at rustasiaconf.com. We can't wait to see you there. Now, back to the episode. Today, I'm with Peter Memery.
Yep.
Or Pete Memery, depends on how you're feeling.
Yeah,
who is the Chief Research Officer,
Yep.
I almost said scientist, officer at ExpressVPN. So we're doing an in-person recording because we're actually not that far away. We're based out of North Point, so it's like 10, 20 minute.
That's not bad.
Yeah, 10, 20 minute ride over here. And, since we got talking, I mean, you're big supporters of Rust because of your use of Rust, and we have the conference we're running.
Yep.
And we thought we would just do a recording in person since we already got acquainted, right?
Yeah.
And check out the office. Let's kind of roll back a little bit about, yourself, right? Because it's good to know, who's this guy? Why should I listen to what he has to say?
Yep.
Can you talk a little bit about, your history with just programming in general? It doesn't have to be about Rust right now.
Sure. I mean, I've actually been programming since I was 8 years old. I was one of the Commodore 64 guys rather than the Spectrum guys. The ability to play games on it, you need the data set constantly breaking in the shop more than you had it at home. So unless you wanted to go through the manual, there was literally nothing else you could do with this thing. So given I wanted to play with it, I just had to pick it up. I was just fascinated by being able to interact with a device and actually create. Not particularly skilled in my hands, things like woodwork, metalwork, they're not for me, but I love the fact that I could create worlds, I could solve problems, I could do all this cool stuff with a computer. I've been teaching programming since I was 11. I've been using it throughout my entire life. And almost all the roles that I've had, both obviously this one, but my previous role in high frequency finance, so as a market maker, even though they're not necessarily directly software related, it's always come to the forefront. So no matter what I've been supposedly doing, the ability to create and do things with any programming language has always kind of shifted my direction in basically every company I was in. Mostly because I could use that skill and I could solve problems that had been bothering the business for years or weren't considered solvable, or just creating something new that added value.
Okay, so does this mean that you've been, because you're saying you had to be able to solve problems? I mean, that relates to what you're doing right now within research, right?
Yep.
Where you need to kind of find the solution or find something new. So basically, your kind of career has led you to where you are now, basically, because you've been kind of, like I said, finding solutions. Now, how did you go from finance to here? Because that's a kind of that's not really exactly related to a certain extent, right?
No, in many ways they're completely unrelated.
Yeah.
But in finance, a lot of my work was done on the low level protocols. So understanding how market data is received, how it can be processed. Is there anything in the structure of that market data that might be helpful to process it faster or send orders faster?
Mm-hmm.
So a lot of my work was on the kind of the esoteric, the weird area, where if you implement these things properly, of course they will work, but if you delve into the protocols, you understand how they work at a lower level, you can do certain tweaks and tricks based on what you want to actually achieve that a normal or a standard system just wouldn't work for. What was really interesting to me about Express was the dedication to privacy, something bigger. In finance, it's the money.
Yeah.
So a global game played with some really smart people, and the score is kept in dollars, and that's cool. But I didn't feel I was really helping anyone or doing anything kind of interesting with my life. I wanted to do more. And so I heard about ExpressVPN, its dedication to privacy, to security, to building the best tech possible, no exceptions. And so, yeah, I reached out. Turns out all that fiddling with low-level network stuff that I've been doing for years was really beneficial here. I was able to benchmark the VPN stuff and ultimately create Lightway as a whole new protocol. Again, solving real world issues.
That's pretty interesting, right? So actually, some of your work does overlap from finance to here. Like you said, you could. I mean, I'm sure if with finance, I'm sure you're doing a lot of benchmarking in terms of like
Yeah.
how can I make this faster. And then you said you're doing benchmarking at
Yep.
ExpressVPN. So did you find that a lot of that actually did overlap?
A lot of that stuff did. So they're
Yeah.
very kind of compatible tools. Most people who were building, VPN companies at the time, especially when it kind of became popular, again, it's open source stuff. So at the time, you would see Linux servers, you'd see OpenVPN, and there was a lot of like talk about how you could tweak it, how you could do this, how you could do that. But when you're running a network for millions of users, you need a bit more than that. And so
Hmm.
what I was able to bring was a more robust quantitative look at how we were doing performance. So in this case, I built a lab that took all the different parameters for OpenVPN and then cross compared them, ran the benchmarks, and said, okay, for these users, this one's better. But it turns out that if you've got this system, actually, you want this configuration. So it kind of changed how we looked at and building and deploying the VPN, and having numbers that really told that story, where you could look at it and go like, this makes sense. This is now we have this. It's kind of obvious what we should do next. It kind of turbocharged what was already a data-driven environment, but it hadn't been done on the tech side to quite that level before I did that.
Yeah, I find that quite interesting because for me, I'm thinking VPN companies. I mean, they're probably there's like standards, right? Like maybe in this situation, use this protocol. This that situation,
Yep.
use that protocol. For a VPN company to invest into making a new protocol, it there has to be a reason why, right?
Yeah.
So Lightway obviously came from a reason. Can you talk more about that reason? And my understanding is that you came in from the beginning. You did a lot of the work on that, right?
Yeah, so I actually created Lightway. So I designed the original protocol
Hmm.
and got it to the point where it was like prototyped, and I did a lot of the work on the initial releases for it into production.
Hmm.
Lightway is kind of unique in the sense that people look at it and they'll say, "Well, hang on." Again, just like you said, like, well, there's other things out there. They're already open. Why would you go and build your own? And the answer is like what we needed just wasn't really there. Now, until like the late, I think 2019, something like that, everybody was pretty much using WireGuard. Sorry, not WireGuard, OpenVPN. Occasionally, like IKEv2 here and there for the platforms that supported it, and usually some like really old protocols for the device you bought 10 years ago that you still really want to use, and you're not necessarily too concerned about the security of it, like a router you might use for streaming, for example. The What happened then though was WireGuard hit the scene, and WireGuard was hitting speeds that no one had really seen before in the VPN space. Its design was completely different. The architecture is different, and all of a sudden, everybody was like, "Wait, VPNs can do this." The problem, though, was although WireGuard is, I mean, it's an amazing protocol. It's very simple. It's very elegant, but it is mostly for I wouldn't necessarily say smaller deployments, but the idea is that almost that you know who you're peering with because you're
Hmm.
exchanging the keys. This isn't ideal if you're running, say, like a consumer focused VPN network where you've got millions of users and thousands of servers. How do you take WireGuard and use it there whilst keeping kind of like the WireGuard essence? The answer to that really is you can't, because a lot of things that you want for a consumer VPN like just doesn't match the way WireGuard works. So one of the things that we tell people is, well, Lightway was inspired by WireGuard,
Hmm.
hands down, no discussion about that. But it was also built on the foundations of OpenVPN. We'd used that for over a decade. Like we knew it well, we knew the structure. It was easy to work with. You can log in with username and password. IP addresses are effectively randomly assigned. It has a lot of benefits for what we want to do. But unfortunately, it was designed in an era where you had PCs on desks with cables, and today we're dealing with cellular devices that are constantly moving between different Wi-Fi hotspots. They're moving between different networks. Like it really wasn't built for that type of technology. And so what Lightway was really kind of our opinionated idea for a VPN. Like what do we need to bring the best to our customers, to give them the best security, to give them the best performance, and to make it easy and to roll out and easy to scale, all that sort of stuff.
Mhm.
And so we built Lightway. So it was inspired by WireGuard. It's grounded really in OpenVPN. It's secured by Wolf SSL, so we didn't build our own crypto. There's none of those shenanigans going on. But it really was engineered for our specific use case to make sure that we met our needs. So it is an opinionated protocol in that sense. But a lot of people want the same thing. And so that's one of the reasons why we were happy to open source it. Like we wanted to kind of share what we'd built back with the world.
Yeah, I mean that because you spent a lot of resources to make this kind of protocol. Why not just keep that yourself, and that could just be your selling point of using ExpressVPN?
That conversation did come up, but it wasn't. It was never kind of taken too seriously.
Mhm.
The reason for that is we've always been strong proponents of open source. That the business fundamentally is built on open source technologies. A lot of the people working on this owe their careers to open source technologies. I mean, I certainly do. And there's also the side of the trust aspect to it. So we wanted to build something that was going to be good, but we didn't want people to have to take our word for it.
Mhm.
And so, although we've done like multiple audits on Lightway, in all of its kind of incarnations, one of the reasons open source is to say here is the source code, check for yourself. And of course, when we did this, actually, we released I think it's one of the biggest bug bounties on, and I just blanked on the which website we used that. Was it? I think was it something like the bug? I'll find that for you later. But we had one like the biggest bounties available for bugs. I think it was $100,000 at the time. So if you could file a critical error or a critical flaw in either Lightway or Trusted Server, the bounty you could claim for that was 100,000. I think other people have now offered similar amounts for other projects, but at the time it was the highest bounty on bug crowd. That's what I
Mm,
was looking for.
okay. So did that yield anything?
No, as far as we know, no one's ever
Oh,
actually
so
no
you're
one's ever
the
tried to claim
challenge
it.
is still there, right?
The challenge is still there,
Okay.
and we welcome the challenge.
Yeah.
I know a lot of places might think of this as more of a marketing stunt, and of course there are some benefits to it in that sense. But we really do encourage people to try, and we do pay out bounties. So sometimes like someone will find like a very minor like a UI issue or some tiny thing that's in terms of security is not a massive threat to anyone. It's just one of those things. But again, we do pay out bounties for that. Obviously, not as much, but we do want to keep that sort of community alive and that community engaged. So if anyone finds anything of any sort of significance, like we do like to, you know, pay out on that. So
Sure.
sign up for the bug crowd and have a go if anyone's interested.
Now I'm kind of curious about when you once you open sourced it. I'm guessing other providers of VPN services and also other IT people who use VPNs have probably reached out and maybe even committed or given some work back. I mean, has there been anything like that that's happened, or has it just been you put it out there and people are kind of using it or just examining it?
So the when we originally released it, it's released as C source code. And the way we've done it is to make it a library, actually very similar in concept to the way Wolf SSL works. So we kind of provide you this, I wouldn't say black box because it's open source, but
Mhm.
it's a library you can load and you wire up the callbacks and you can pretty do anything you want with it. The most fun one we've seen is a lightweight over Google Sheets,
Okay.
where it uses Google API to connect to the sheet, and then one side writes to the first column, the other side writes to the other, and then they switch for the reading. So you can do some pretty cool stuff with it. To the best of my knowledge, though, no one really did. And part of the reason for that is we did build a demo app to kind of showcase it, but it really was a demo app,
Hmm.
and we didn't do a great job of building the community around it. The tooling just wasn't there. That's one of the things that we fixed with the Rust release. So lightweight Rust has already been released open source. This time we still have the same design where we have this core library that provides all the functionality, but we also have a fully functional client and a fully functional server that is part of that project. So you can build and run your own lightweight instance, just with what's available. And again, like we're hoping to get that properly packaged, and maybe one day you'll be able to apt-get install lightweight would be kind of cool.
Well, so we're almost into the next part, right? But I want to talk a little bit more about lightweight, and it's written in C, and then obviously you've already given away the surprises as was rewritten in Rust. So I'd like to talk a little bit about like why was it chosen in C, and I'm guessing it was working for some time, at least as far as I know. And what was the discussion of why rewrite in Rust? Because that's one of the things that people like to say about people who like to write Rust is like, oh, just rewrite in Rust, which is not always the best thing to do, right?
Yeah, there are some challenges with it, and it really is a commitment.
Or let's talk about why and C, and then how we get
Yep.
to where we are now.
So again, back in around 2019, if you wanted to stream things like any streaming service in in this case in HD even, if you had one of the standard routers of the day, they weren't really that strong when it came to VPNs. So if you put OpenVPN on it, it would struggle to get you near the sort of throughput you would need to watch any sort of realistic stream.
Mhm.
So the common solution to that at the time was to offer things like L2TP and PPTP, which were known for having poor security, but they were significantly faster. Now, these weren't offered for security, of course, they were only for streaming, and the industry was very clear, like this will work, but if all you care about is doing your streaming, this will work well for you, but don't use it for anything other than that. And that's also obviously a problem. So what we needed Lightweight to do was to be, it had to, match WireGuard, pound for pound in terms of like potential performance. But we had a huge number of our users who were using either older routers or were using, say, Android devices that were from like developing markets. And in order to get the performance out of those, you needed something that could really, go down to the hardware and just take like full advantage of it. Now, Wolf SSL is actually amazing at that. A lot of the work that they've done has been in doing optimization for all these random chipsets and like CPU architectures. So, is designed to be embedded, and so that could help you eke out that speed you needed. The problem at the time, and I did look at Rust. I've always been fascinated by Rust due to its memory model. I really like the way it does that, and I love the security guarantees that it gives. Now previously I'd written lots of stuff in C. C has a lot of sharp edges, and it's very, very easy to slice off your fingers, almost too easy. Because again, C just assumes you know what you're doing, and if you don't, or you made a mistake, at some point you will pay for it. So what we needed back then was something that would give us this performance. We tried with Rust, and it just wasn't there yet. For a lot of the platforms, it wasn't really well supported. We couldn't actually get a high quality build. And we also had the problem of the raw performance. If we're going to put this on our servers where we're going to have thousands of users connected to it, this thing has to really move. And although would have had these amazing benefits at that time, based on our tests, like Rust just wasn't there yet.
That makes sense. So at what point did Rust actually become there, and how did you figure that out? Were you just following on the updates and saw that certain features were there that you needed, or would you just try it, come back, try it, come back?
So the promise of Rust kind of never left. I started using it for a lot of like relatively minor projects, small tools, helper utilities, stuff like that. And of course, I'm showing this to my friends, my colleagues. They're looking at it going, this looks cool. How do I do that? And one of the things actually we found that was quite surprising was historically, again, this is true for me at least. If I needed performance, I would have written it in C. If I just needed some code to do something, I mean, I played with all sorts of languages, including things like Erlang, Elixir, and stuff like that. But generally, Python was the tool that I would reach for. But what I was seeing was I was actually able to build the tools faster in Rust with much greater performance, much less hassle, and it would just build and run everywhere. Plus, be much easier to package and distribute. That I stopped reaching for Python. Still had the C for the high performance stuff, but Rust was working pretty well. And other people, because again, we're in a privacy and security focused industry, and ExpressVPN in particular is very focused on the privacy aspects. So the people that we tend to end up working here, they're also in with that same mindset. They're also really interested in this. So it was kind of like a natural sort of draw to these people. Like when they started seeing it actually, being used and working and still delivering all these features, but also being easy to use and having things like amazing error messages that you can actually make sense and often tells you what you've done wrong. It really drew a lot of people in. And over the years, Rust got significantly faster, and there were more enhancements to it. It got to the point around, I think, early 2024, something like that, where we kind of sat down and said, well, Lightweight's working great. There's nothing wrong with the C version. It's audited, it's secure, it works, it delivers. But Lightweight could do so much more than it's doing now. But if we were to expand Lightweight and invest in all of those new things, is this really the base that we would want to do it from? And that's when we relooked at Rust and found actually the main stumbling blocks that we had before don't seem to exist anymore. Like there are targets for these platforms. The performance is actually pretty nice. And we didn't want to stop using Wolf SSL, but we were able to build bindings for that. I would say almost trivially, like scarily trivially, that we were able to effectively just in an evening set this up. And when we tested it, it worked. And this was kind of, very eye-opening in the sense, well, we can kind of have our cake and eat it now. Of course, it's unsafe Rust for that part of it, but that's better than just regular C. And then we can build all of Lightweight in safe Rust. And then it was like, well, what will that look like? And then we started looking more at the language. And there's lots of benefits to it. There's some amazing crates out there. There's some amazing architectures, for example, like Tokyo and stuff like that. But even simple things like which hash map to use. Like when you're working in C, that's a very big question that you have to spend time on. Which library will you pick? Where will you pull it from? How are you going to build it? Does it work well on all of the platforms that support it? Whereas in Rust, you don't have that issue. So in many ways, we greatly simplified like the mental burden of building and extending, but we also had this promise of the security benefits. And as soon as we had the performance to match it, it was pretty much a no-brainer to kind of move forward in that direction.
Okay, no, that definitely makes sense. Because there's always, like I said, that concern, like if it works, why rebuild it? And I definitely heard that before, where it's like, well, yeah, we have this thing working, but if we start to expand it, it could be like a house of cards, basically, is what it sounds like you were almost heading into. Now you talk about your your use of other languages, right? You're not a Rust only person, C only person, etc. Can we talk more about like how does Rust stand out compared to C, C++, and Go, right? Go is often compared with Rust, even though to me they're like not really similar.
Yeah, so I mean, it's an interesting question. Rust for me right now, like one way of looking at this is with Rust, you can write firmware for a little crypto USB device, or you can build a massively scalable web service. And what's telling is that when you do either of those, Rust fits. Normally, what you'd find is you're having to bend rules. You're having to stretch
Mhm.
things or push things in directions they weren't meant to go. But Rust naturally feels nice in all of those environments. That's a huge thing. And for us, we found that developing some of our core logic, we now have some of our internal SDKs. They're written in Rust and on the client side, but they're sharing code for, say, auth token generation or validation with the APIs doing the web services. And it's the same people writing and managing the entire stack.
Yeah.
So it's super beneficial from that point of view. I think what makes it stand out against, in particular, C, and this, to be fair, this is only relatively recently in the sense that like C dominates a very specific market segment where you need that low level control and power. It's assembly or it's C. But I think Rust is very much coming to eat C's lunch because I'm seeing many locations now where Rust is actually beating C in terms of performance. And if I get to build in a high level language where I'm not worrying about all these low level details and I get that better performance, I mean, after all with C, part of the reason why you are filling with those little bits and pieces is because you're optimizing or you're trying to get the best speed out of it. If it turns out that actually you can stop doing all of that and be faster, ignoring all the safety aspects,
Mhm.
that is a huge win. So the assumption for a lot of people is still, well, C is still faster. Actually, in our tests, that's no longer the case. For certain things, of course,
Yeah.
Rust can beat C. In terms of Python, I mean, Python has so much like love and support, has an amazing community. You can find, a package to do almost everything. But I found the same to be similarly true for the Rust community. It's extremely welcoming. There's some amazing projects going on. The only minor issue, if you really, is that there's usually more than one crate to do something because everyone's excited, everyone's getting involved, everyone's creating. And sometimes it can be hard to figure out, should I use this one or should I use that one? But even then, you tend to there usually tends to be one kind of leader that kind of stands out a bit from the pack. And because writing Rust, once you're familiar with it, can actually be, I mean, in my case, I can write in Rust fast and I can write in Python. That means the main reason for me writing Python in the first place is kind of, been superseded. I'm not faster writing in Python. And the binaries are certainly, not faster in Python. And if you've ever tried shipping Python code anywhere, yes, it's batteries included, but you've got to drag the batteries along with it. With Rust, with the standard binary, it's effectively trivial, especially because I can build it for Linux, Mac, and Windows, and it, depending on the crates, of course, but
Yeah.
mostly it just works. Compared to Go, I mean, I was very excited about Go when it first came out. I gave a lecture on Go and the benefits to using Go at one of the universities here. I I built a large trading stuff in Erlang, which is a massively multi currency language, and it could do things that you just couldn't do in C. In the sense, it was the only time I saw what was at the time a big server, 48 cores, and if you went in the top and you looked at the CPUs, all of them moved in pure lockstep. It was that good at like distributing the load across the machine, but it wasn't great at doing the low level things that you could kind of do in C. And so for me, Go was super exciting because you got the coroutines and stuff that looked very Erlang-esque, where you could do the same sort of easy concurrency,
Mhm.
but you didn't need to run this whole beam environment. You ended up with a binary. I ultimately didn't get super far with Go, mostly I suspect because the language didn't really speak to me, and I wasn't really working in the areas where Go became like extremely popular, like web services and the cloud side of things. I was mostly working on like bare metal, like close to the hardware. And in that sense, if you compare, say, Rust to Go, I mean, I don't feel there's a comparison there. I think a lot of people said, "Oh, that Go is going to be the successor to C." I don't think that's the case. Rust is very much, to me, better place to be the successor because it already does everything that C can do, and you still keep that low level power if you need it. So I still Go still has a place. Obviously, it's obviously a very popular language, and it does make building certain services like really easy. But based on our experience here building similar services in Rust is no slack either. And once you get used to the frameworks, you can spin up new APIs and new services surprisingly quickly. So I think Rust is going to eat C's lunch. It's probably coming for Python too in many ways. And yeah, I don't think Go should feel too safe either. It's going to be interesting to see how it all turns out, but Rust has the potential to kind of get a seat at the table at almost any of these sorts of like I wouldn't say niche, but any of these sort of like specialized areas. It just seems to fit well for almost everything.
Well, what about something like Zig or D? I mean, I heard a lot of people talking about D, but I don't barely ever hear about D anymore. But I think Zig is kind of slowly, like in the background somewhere, people are kind of saying, this is better. You talk about Elixir. I do a lot of Elixir basically every day. And it seems like people, when you need to write some type of NIF, which I think you've heard before,
Yep.
native implemented function, people recommend you use Zig instead of Rust. So have you ever looked at Zig and seen, if that's something that could also be either replacement for where you're using Rust or maybe side by side where it has some strengths or some weaknesses?
So I looked at a lot of languages that were claiming to operate in Rust's space, or like the competitors to it.
Yeah.
But the experience was very different. And with Rust, it felt like I was getting this kind of, on the one hand, this big industry tool that I could effectively like change the world with. Like it felt powerful, and there was a lot of excitement about it. And the reason for it to exist, kind of like the history of it, where it came from, was a super compelling story. I did do some like basic stuff with these other languages. I did try Zig. I did try, I think it was D, and I did try another one whose name unfortunately I can't remember. But they didn't feel, for me, they didn't feel as polished. They were very interesting, but with Rust, I was able to almost immediately do my day job in it if I'd
Mhm.
wanted to. With these other languages, I didn't feel they had reached that level of maturity and that level of interest, if you like, that would make them true competitors. Whether that will stay the case, I don't know. I mean, you've seen how languages work.
Yeah.
They're always leapfrogging each other, and I think it's very definitely interesting and important to have these because they keep every language kind of honest. Because you can't say, "Oh, I have this amazing feature and mine's the best and it works this way," when someone says, "Yeah, but this language over here that's also working pretty well doesn't do it your way and it's just as good." These sorts of like hotpots of individual kind of like ideas and stuff like that. Again, we always see languages kind of borrowing from each other.
Yeah.
That I think is really important. I have built a lot of NIFs for Erlang. Those were in C, and I can't think of any reason why I would reach for, say, for Zig instead of Rust off the top of my head. I mean, I've not dug into it, I've not done it for a while, but
Yeah.
I can't think of a reason why I would. And for me, I'm very much one of those guys. I mean, I don't, when someone says, "Oh, I'm a Python engineer," or "I'm a C engineer," like for me, you're an engineer, and like the language is just the tool that you express the solution in. So when I was building this market data system, like Erlang was the obvious thing for me. It gave me incredible speed to build, and like it was almost impossible to kill the thing. It was like self-regenerating. It was honestly it was amazing to watch this thing kind of in action. None of which is due to my code. It's just due to how nice the language is. Same for Elixir. So I would always reach for the thing that was the best tool for the job, or what I thought was the best tool for the job. So I wouldn't be opposed to picking up Zig and potentially using it for projects or for even potentially trying to use it with Rust. I just haven't had the need yet to kind of think, the main tool that we're using, it's missing an edge, at least not a significant enough edge to start looking at again at the alternatives.
Okay. Well, so now that you've had Rust and ExpressVPN for quite some time, how does it help to improve the performance and reliability of ExpressVPN actually operating?
So the Rust version of Lightweight is still being deployed. We already have it on a number of servers across our fleet. We're rolling that out over the next few weeks. Um, we're not having any issues with it. We're just being cautious, taking our time. We're integrating it with our Android app as the first app that's going to take the new Rust core, and then we're then working across the other apps to upgrade those as well. It is important to remember that there's nothing wrong with the C core that's currently in them, and that's partly why we're taking our time with the upgrades, because we want to make sure that when we integrate with the different platforms, that we take advantage of what the platform offers. So we're no super rush to roll it out, but effectively all our new development and all of our new tech will be based on the Rust versions.
That definitely helps a lot because if you have like one solid core, you can fix a bug or whatever in all of them. But then again, you also have the opposite effect of if you have a bug in your central core,
Yep,
then it's in all
everything
of
has it.
them, right?
Yep.
Now this is kind of interesting too because this question I have over here: when you're working together with Rust, I mean, and it sounds like you're sharing a lot of code. How has the collaboration process been at ExpressVPN in terms of like adding new features? Because when you write code, right, somebody could make a choice, a decision that will just affect everybody else because you don't have a dynamic language like Python where you can kind of duck type your way out of something.
Mm.
With this one, it's no, you have to have this particular thing. So if somebody makes a big change, that could be a big problem for everybody else, depending on these core libraries, right?
Yep. So there's been different approaches to that depending on where the Rust is being used. So for the core VPN team, which builds the core lightweight stuff, we're a fairly close knit team. We're always in communication. We're always like brainstorming together and coming up with ideas about how we want to take it forward. And often, one person will have the idea, and then it gets passed to someone else to actually investigate or implement or look at, just to kind of share that kind of to prevent the echo chamber problem. So a lot of the bigger questions about the architecture kind of answer themselves because we're kind of doing it in a more of a combined way, right? So a bit of a shared brain scenario there. For the web services that we're building, it's slightly different. When we first started building them, we didn't have a lot of experience using Rust for this, but we decided at the time, well, when we do build this, we're willing to throw this away. So we're not new to Rust, but we're new to building this stuff with it. Let's iterate on it, see what we learn, and see how this works. And what we ended up with there is effectively like a client SDK framework, which has some of the benefits of Ruby on Rails, in the sense that if you write your code in a certain way, you get for free, you get metrics, you get auto configuration, you get access to all these other features. Oh, and those libraries can find you as well. If you don't interact that way, your life is going to suck when you try to integrate this. And by the way, you're the one who's going to have to integrate it. So we have this kind of like, I wouldn't say syntactic sugar, but it's like a syntactic framework in the sense that there's a way that everyone seems to have agreed to do it. And as long as you kind of, follow that sort of path, all your stuff will just be easy. That said, like it's not locked in stone. So we are iterating over the framework itself. When a new project comes up where it's like, well, the way we handle, say, packets is one by one, but I want to make something that splits a packet in half or duplicates packets. Well, that doesn't work. Like you have to pack it in, pack it out. Okay, we need something new for this. And then, we figure out what that looks like. We add it to SDK, and now there is kind of a standard way of doing it. May not be a perfect standard, but if anybody else wants to play with packets, there is standard in there, and everybody can kind of benefit from it. And of course, if there's problems, you can upgrade it, tweak it, and so on. So those are two kind of like separate but related teams, and their projects work slightly differently because of it. But we've not really found it to be a massive problem. People tend to self-organize with this. They know the sorts of complexity of what we're building and how we're building it, and the teams effectively have the flexibility to talk to each other and figure out, well, what makes sense for this team, what makes sense for this project. And that flexibility, I think, stops us having that problem where it's like, no, this is the law, this is how it must be done. And then you start seeing all that code that tries to work around the rules, and then we avoid that problem entirely, thankfully.
That's good to hear. So now that you've been writing Rust for a while, right? Obviously, you have new engineers that come join the company. You probably do some type of internal training, or you have a process. I'm kind of curious about if somebody who came up to you and doesn't have to actually be working here, but they ask you for some advice about if I'm writing something that's high performance in Rust. Do you have any kind of advice for them about how to do that? Because obviously you've been doing high performance applications for a while, and now with Rust you're doing it again, right? So what kind of advice would you give to them?
So is this if they're new to Rust, or if they're just look at the high performance stuff?
Let's say they're new to Rust but have some programming experience.
Yep. So the first thing that I would recommend most people do is start looking at the Rust book.
When you say the Rust book, you mean the actual Rust book that's on Markdown? I think that's everybody can see. Okay.
Yeah, I've got one. I got one of the printed copies. It's like a further dead tree version usually.
Yeah.
And the reason for that is, I found that a lot of people who are just even interested in Rust will get quite far into the book without even actually writing a line of code, but it's so nicely written, and it tells this narrative, this story, that you're constantly turning the page to uncover what secret comes next. Usually by that point, you start to get a feel for what you're getting yourself into with this. And so for a lot of people, they might do that and go, well, actually, I'll just keep doing what I'm doing. But other people are like, well, actually, this looks kind of cool. This looks kind of interesting. I want to know more. And we found that the Rustlings project is actually quite nice for getting people who prefer the hands-on training with Rust. We found that actually for a lot of people that really, if they've already got programming experience, this kind of accelerates them quite quickly if they're given the time to do it. So saying, oh, here's Rustlings, do it in your spare time, doesn't work. It's, here is a block of time, go work through these. Have fun with it, enjoy it, but you have time to think this through and work through it. That seems to get most people to the point where they can start understanding how the high performance stuff that they would have done in the other language would possibly map to Rust. That's kind of key, because now you can search for things. There is a really nice guide that we have it on our internal wiki, but I think it's the embedded. I'm not sure it's called the embedded book. There is one that focuses on doing things with low-level hardware and what do you do if you don't have standard and stuff like that. And that's where you kind of see some of I wouldn't say the darker side, but some of the secrets of the language that you can tap into. A lot of people read that and say, well, I didn't get half of that, so I'm going to stay away from this bit, but this bit over here still looks better. Whereas others just kind of lap it up and start doing some more of the arcane sort of stuff that you can do with Rust. So it really depends on what project they actually want to kick off. There's a big difference, for example, between say a high performance website and high performance network server. What's interesting with Rust though is if you want to build a high performance network server, you can kind of pick up Tokyo and you're pretty much 90% of the way there. You can start out with a very basic, simple implementation without doing anything that's advanced, and you benchmark it, and you often find actually that's significantly faster than what I was doing before. So we have seen that a lot, where people have said, I want to come learn Rust. I've got all this cool stuff that I do. I make my own custom hash maps, and I have my own way of stacking arrays to get the best performance out of it. Can I do this in Rust? And it's like, you can. However, you probably shouldn't.
Yeah.
Go try this first, see how you're going with that, and then let's talk. And most people come back and say, yeah, I did all that stuff that I built before. Turns out, yeah, I didn't need it. I've either found the standard crates work, or I found a crate written by somebody else who had the same issue as me, but is like 10 steps ahead of what I was thinking. So I used their crate, and it's way better than what I could possibly have done. And they've solved these edge cases that I hadn't even considered. That has happened more than once.
Okay. Then I'd like to talk a little bit more about your investment into Rust itself, right?
Yep.
So it sounds like, which is great to hear, because there's too many companies that are more consumers of open source and
Yep.
consumers of technology and never really giving back. But now you're starting to give back, right?
Yep.
Hint, hint. You're working with us on the RUSTAsia conference, so I'd like to
Yep.
hear more about what you're doing and by reaching out in the Rust community, and what's kind of like what are you doing? I guess to say it that way.
So Express has always been a strong proponent of open source. Our platforms are based on it. Our code is based in open source languages. I'm trying to think of anything of that we use that's kind of like critical but not open source versions of it. And the answer would be there's very little. And when you do build like a really successful company on those technologies, you should give back to them.
Mm-hmm.
We don't tend to see that a lot. There's a lot of people that say, well, why would you pay for open source? It's free. That bugs me no end. Like, no, it's given to you for free, but there's hours and hours, or months or years of blood, sweat, and tears that went into creating that thing. And for myself, I've always trying to give it back to open source. So back then I wasn't writing much in the way of code, so I wrote books. I wrote some books on like the Pi, MongoDB, and a few others. So I'm kind of at what were at the time esoteric topics that are now mainstream, because I wanted to kind of give back, and that was something I felt that I could actually do. And that sort of ethos of giving back, because I'm very much aware that like my career where I am now just could not exist without open source. When I left like high school, like I didn't go to university. I actually convinced my school to let me study for a Red Hat certified engineer exam as part of one of my courses. So I was at the time the youngest Red Hat certified engineer. I passed at 17, which it seems insane to even think of that, but I was super excited by this, and I basically built everything from that point onwards on the open source stuff. And so for me, like what I've done wouldn't be possible without open source. And so I really try to give back because I think it's so important. And so, I mean, I personally sponsor various like talks and technologies, throughout the world. I sponsor RUSTAsia. And for me, what was amazing about joining Express was the company thought so too. And that was really cool, because normally I'm like, I'd have to
Just
explain.
like fight for it, right?
Yeah, like I want some money. Why? Because I want to buy this free thing. And it's like, why would you do that? It's free. Like, it doesn't make sense. It's like, it makes a lot of sense. So I would often, and we've done this with a few like smaller projects that we've worked with, where we found some open source software and it's got all the features we want, but maybe one is missing, or there's this one tweak that we need. And if we can write it, we'll write it and we'll contribute it. But often, we'll reach out to the developer or the project and say, look, hey, what you've got is amazing. Like, we'd really love to use it. If we were to give you like this bounty, would you be able to add this for us? And most projects are super happy to well, one, they're happy that someone's cares about their project and wants to be involved in it and can see the vision. But it also means the difference. Say you offered a bounty of $500, $1,000 for an individual who's dedicating their spare time to building this project. That's potentially a huge amount of money for them.
Mm-hmm.
But for a large corporation, it's not so significant. And the value that you will derive from that relatively small payment, shall we say, is many times greater than the investment kind of put into it. The key thing there is everybody wins.
Yeah.
Everybody. The company gets the exact feature it needs. It doesn't need to maintain it. The people that built it are super happy. Maybe they can, buy that new version of the hardware they wanted to test on. Like everybody comes away smiling in that situation. And I think we should see a lot more of this bigger scale. So part of the stuff that we're actively working on is sponsoring and helping get the word out there, both open source, but again, particularly for us. So like we were super excited to see RUSTAsia. I mean, we were kind of wondering where Rust was, particularly where we are.
Yeah.
And so for us, it was really exciting. And we like to get involved. Like when we hear these sorts of things, like cool, that sounds great. I mean, we could do this, we could do that, and it's like cool. Let's reach out. Let's see what we can do. And it's exciting because when you're talking to people who've again taken the time to put together, something like that conference, which let's be honest, it's a work of of love. Like
Yeah.
it's a huge amount of effort. There's an amazing rapport there because you're talking to people who love the same things that you love and care about the same as you care about. And so for us, it's great to be able to get involved and start talking more about Rust and sharing what we're doing because like this is for many cases I feel like if not the way forward, a way forward. And particularly with Hong Kong, we're seeing there's still a lot of languages and use cases that really haven't changed in the last 5-10 years.
I'd say even more than that, but
Yeah. So I think being able to go out and go, look, no, this is a real thing. Like it's really useful. You can build real stuff. Like we are building real stuff. It is successful. It is working by every measurable benchmark, and we want to do more of it. And if this stuff interests you, you can do more of it. Now, part of telling that story and trying to help people learn about this and get started with this, the benefits to a company aren't always, in fact, almost never are kind of instantaneous. But what we're interested in is building the community, enabling the community, and helping that community, kind of flourish and grow, spread the word, because then hopefully more people will do this and more people will
yeah.
talk about it and more people will get involved. And I think with a tool that's potentially this powerful, we've got to talk about it. We've got to share it. One last thing I'll add to that. When we did the first audits of Lightway back in, I think it was 2020, 2021 when we did these, the way that you would attack a VPN, particularly a low level one like Lightway, is you look for buffer overflows, memory issues.
Mm-hmm.
And that's where you'd see all the attacks happening. That's what everyone is looking at. So what was kind of interesting was before we released Lightway in Rust, we commissioned 2 independent security audits, one by Cure 53, one by Praetorian. I think those are online already. If not, they will be in the not too distant future. And we kind of took away their favorite toy. Like Lightway that they were testing, it's all in safe Rust. So you're not going to find these buffer overflow issues. You're not going to find the off by one issues. And given that that was the focus of us writing it in C and like being super careful and meticulous, and then the auditors doing the same thing kind of in reverse, where they're trying to pull things apart and being equally meticulous. When you go to the land of Rust, that entire concept ceases to exist. And what's interesting is it's not, well, it's really hard to make this mistake in Rust, or it's really easy to get it right. It's like it doesn't happen. Now, I'll caveat with the case that there are things that you can do where you can deliberately do silly stuff. But if you're, honestly writing Rust code, you're not going to be able to create these scenarios. And given that those are the most dangerous scenarios and that have the biggest impact, I think Microsoft did a report, it was years ago now, 5, 6 years ago, I think, but they looked at all the bugs and things that they'd ever kind of worked on. And there was something like 78%, like for some reason that number stuck in my head, of the bugs that had been security related were to do with memory handling.
Yeah.
And none of that class of bug exists or can exist in the new lightweight code base. It's I mean, we're still meticulous about the security,
Sure.
don't get me wrong, but the fact that the language has our back and, protects us from this entire class of, really scary things it's incredible. It's such a powerful tool.
Yeah, that's a good point. I think we're trying to approach the end of our time. Is there anything that you wanted to say before we close? Otherwise, I have one last question. I think that's maybe
Yep.
we'll stump you. So, is there anything else on
Okay.
your side?
Nothing in particular.
Okay.
Let's stump
So
me.
you ready for this one? I'm not sure if stump is the right word, but this is a good one. So, if you had to describe Rust in 3 words, what would they be? See, this one I told you is a little bit
Oh
of a
yeah, okay,
doozy.
that's a thinker.
Yeah,
I'm gonna go with the way forward.
the way forward. That's a pretty bold statement to make.
It's a bold statement. I feel I can back that up with a lot of things. The reason I say it's the way forward is for all the projects that I have personally worked on over, oh dear, a quarter of a century. I can't think of any off the top of my head where Rust would either have not made it easier for me to do so, given me better performance, or offered me better protection from, the silly finger slicing that you can get off a language like C. I'm sure there are, and again, I'm talking about Rust as it stands
Hmm.
today. But yeah, I think for many of us, this would be the way forward. If for no other reason than that if you, maybe you're not an expert in Rust, but if you knew Rust, if you understood what it's doing, why it's doing it, the just that insight, even if you never touch Rust ever again, it will change how you write C code and how you think about C code. It'll make you appreciate the runtime differences that you're seeing in Python, and you can see what the language is doing for you. Yes, you get all these benefits of it being dynamically typed, but now you can see the costs. These are all things that you don't generally see unless you have something that you can kind of compare them against. And I think, if nothing else, Rust will serve as that comparator.
Okay. Well, it was great chatting with you and hearing more about Express's use of Rust. And yeah, we'll see you at the conference. And
Yeah,
now that
looking forward to
we're
it.
not far away, we can definitely have another episode later on. Maybe there's a V3 or something that happens with Lightweight or some other
Yeah,
kind of thing
no,
breaks through.
I would love to.